Good evening everyone. Welcome to tonight's presentation on vectors, equations of lines and planes, and exercises with short and long answer problems. I'm excited to present the key concepts and insights around this topic. Let's get started. Vector equations can be employed to express a line or a plane in three-dimensional space. A vector equation of a line is constructed by 2 points on the line. The vector equation of a plane is constructed by 3 points on the plane. These vector equations are beneficial for resolving difficulties associated with distance, angles, and crossings of lines and planes. The vector equation for this straight line is given by adding the point 2, 3, minus 1, and the vector 1, minus 2, 3. This line goes through the point 2, 3, minus 1, and is in the same direction as the vector 1, minus 2, 3. Consequently, the equation of the line can be written as 2, 3, minus 1, plus t, 1, minus 2, 3, where t is a real number. An example of adding 2 vectors is illustrated in this slide. The Cartesian equation of the line passing through the 2 points is given, and the result is expressed as the sum of the 2 vectors. The diagram shows each step of the procedure, providing a visual representation of the solution. This method demonstrates how 2 vectors can be combined to form a third vector. A vector equation of a plane can be used to describe the behavior of a plane in 3D space. Using the given point A, the normal vector of the plane can be calculated, which will then show the orientation of the plane. To find the components of the vector equation, the necessary equations need to be solved. Once the normal vector has been solved for, we can calculate the plane passing through point A. We can see from the given equation that when 2 vectors are added, the resulting vector is equal to the sum of the individual vector components. In this example, the resulting vector is equal to the sum of the individual vector components, x1 plus x2 and y1 plus y2. Thus, vector addition is a useful tool for describing motion in 2 dimensions. Given the coordinates of 3 points, the equation of the plane passing through them can be calculated by considering the Cartesian equation of the plane to be equal to 0. This is an essential step in understanding the properties of a plane, as the addition of vectors is fundamental. In this exercise, we'll be exploring how to add 2 vectors together. To start, let's look at the concept of vector components. A vector can be split into 2 components, an x component and a y component. When we add 2 vectors, we add their components together, like this. A plus b equals c. After adding the components of 2 vectors together, we get a third vector, which is equal to the sum of the 2 original vectors. We can then use this result to graphically visualize the addition of the 2 vectors. The vector equation demonstrates that the combining of vectors can be expressed as a sole vector. The size and path of the resultant vector are elucidated by the individual vectors and their arrangements. This concept can be employed for multiple vectors. Applying the parallelogram law of vector addition, vector OC is equal to the vector sum of OA and OB multiplied by a scalar t. This equation can be used to determine the solution. We will discuss the vector equation of the median through the vertex A, examining the components B, C, and A along with an added D component to create a comprehensive equation. Applying mathematical principles, we will figure out how to combine vectors in distinct and potent methods. Let's take a look. Solution for vector equation of plane is an equation that states two vectors when added together will result in a third vector that is perpendicular to the first two vectors. This equation provides insight into the motion of objects and is essential for calculations in physics and engineering. Using this equation helps understand the motion of objects in 3D space. The vector equation of a plane can be obtained by taking the cross product of 3 points that exist on it. In this instance, 0, 0, 0, 0, 5, 0, and 2, 0, 1 are being used. Calculating the cross product of these 3 points yields the vector equation of the plane, giving us the desired result. We'll be looking into the concept of adding vectors in exercise 4.3. This involves combining 2 or more vectors to create a single vector where the sum of all the added vectors is the result. To calculate the sum of vectors, we need to consider the direction of each vector and add them together. This sum of vectors can then be used to determine the resultant vector, as well as to calculate the magnitude and direction of the force. From the equation in this slide, minus 1t equals 3 plus 3s when t equals minus 1 and s equals minus 1. Substituting t equals minus 1 in the first equation gives 2 plus t equals 1. 3 plus t equals 2 minus 4s and minus 1t equals 3 plus 3s, which leads to the conclusion that t equals minus 1, s equals minus 1. The equation s plus 2t equals 3 indicates that adding 2 vectors s and t gives a result of 3. Likewise, 10s plus 8t equals 5 states that the sum of vectors s and t gives a result of 5. Moreover, minus 6s equals 7 illustrates that subtracting vector s from the equation generates 7 as a result. we are examining how to combine two vectors to generate an equation. Equating 1 and 2, then solving equations 3 and 4, establishes that the value of y is 1 and the value of t is 1. This shows how math can be used to solve complicated equations.